So today we're going to look at section 8.5, but before we do, let's do this warm up for 8.3 and 8.4. So push pause real quick and answer these questions. Now that you've had the chance to do that, let's take a look at these. Number one, we can see that opposite sides are congruent. And if opposite sides are congruent, then we know that we have a parallelogram. On number two, I have one pair of opposite sides that is congruent and also parallel. And this is theorem 8.9 in your book on page 523 that says if I have this, then yes, this is a parallelogram. And then on number three, all I know is that this is 90 degrees, so I don't know anything else about the opposite sides being parallel or congruent, so it's really easy to say this is no, it's not, and it could look something like this. So say that these other two angles other two sides look like this, then it would be clear that this is not a parallelogram because opposite sides are not parallel. So don't always trust the picture, trust the markings. So in 8.5, we're going to talk about trapezoids and kites, and we'll start with trapezoids. So these are some definitions. First, make sure you read 8.5 first before you watch the video. If you haven't read 8.5, press pause and take 10 or 15 minutes to read it on your own. So these are some definitions you should have from your text. But a trapezoid is a quadrilateral with exactly one pair of parallel sides. And the bases of a trapezoid are the parallel sides of the trapezoid. So this is important to know because we're going to refer to these bases a lot, but the bases are the parallel sides. So in this trapezoid, BC would be a base and AD would be a base. And then the legs of the trapezoid would be the non-parallel sides of the trapezoid. So these would be AB and CD. And then base angles of a trapezoid would be a trapezoid has two pairs of angles that have a common side. That is a base of the trapezoid. So we have A and D being base angles. You could also say that B and C would be base angles together. Let's look at an example. We want to graph the vertices of this quadrilateral and decide whether it is a trapezoid or not. So first, remember when you graph, you have x and y coordinates, so x axis and the y axis, and you need to plot these points. And as I work these out, try to push pause on the video and work these out on your own. So first we have A is negative 1, 4. So we have negative 1, 4, which is 1, 2, 3, 4. This would be A. B would be negative 2, 1. C would be 6, negative 3. And D would be 5, 1. And we have to decide if this is a trapezoid or not, and then justify the answer. So it may be helpful just to look and see what we think. So if I were to connect these dots, does it look like a trapezoid? In order to be a trapezoid, we have to have one set of parallel lines. And so it looks like AD might be parallel with BC. It's pretty obvious that AB and DC are not going to be parallel. So let's check the slope of AD. So parallel lines should have the same slope. So if I'm going to do AD, I'm going to do 5 minus negative 1. That's the x coordinate. Let's do the y coordinate. 1 minus 4, and then 5 minus negative 1. And that gives me negative 3 over 6, which is negative 1/2. And then I need to compare that to the slope BC. So still do y2 minus y1. This time it's negative 3 minus 1 over 6 minus negative 2, which gives me negative 4 over 8, which is negative 1/2. And so I've proved that these two lines are parallel, and so I can say this is a trapezoid. So we can say A, B, C, D is a trapezoid. And it doesn't matter what the other lines are like as long as you have one pair of parallel lines. So a couple more definitions here. An isosceles trapezoid is a specific type of trapezoid where I have congruent legs. And if this happens, then the base angles are congruent. So this is congruent to this angle, and then this angle will be congruent to this angle. And it's also true that the diagonals are congruent. So if I drew in this line here, then it's congruent to this line here. So if I want to find the missing angles of an isosceles trapezoid, put this on pause and try to do this on your own. We know right away that these are congruent. So I can have this be 65 and this be 65. I have an isosceles trapezoid. And if I have these parallel lines, I know these are supplementary. So I can do 180 minus 65, which would be 115, to find these angles up here. A few more definitions with trapezoids. We have a midsegment of a trapezoid, which is a segment that connects the midpoints of the legs of the trapezoid. So you have to know these are midpoints. Either you're told or they're marked that these are midpoints. And this BE does not have to be congruent with CF. And then we have this theorem that if I add the bases together and cut it in half, that's what the midsegment is. Or if I take the midsegment times 2, that's equal to the sum of the bases. So let's use this in a couple examples here. So I'm looking for HK, I'm going to call that X. And so if I want to find that, I can do X is equal to half of 6 plus 18. And so X is equal to half of 24. And so X must be 12. And make sure your answer makes sense, because the confusing part here is, do I take it times a half or times 2? And if you take it times 2, you'll get a much bigger number, and this shouldn't be bigger than the largest base. So if you end up getting 48 for this, you would see, well, 48 wouldn't make sense there for HK, so I must have done something incorrectly. Okay, on number 4, hopefully you tried this one on your own already, but we're told this is the midsegment, so I know that and that are congruent, and 3 and y are congruent, so y has to be 3. And then I'm looking for x. That's one of my bases. And so I could do this a couple different ways. I could set it up the same way I did 3, or I could do 12 times 2. So my midsegment times 2 is equal to 9 plus x. So we could do 24 is equal to 9 plus x. And so 15 must be what x is. Next we'll look at kites and some of their properties. So a kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. And so there's a couple examples down here. And the diagonals are perpendicular. So if I draw on the diagonals of a kite, then I have a 90-degree angle right at the middle, which is nice because that creates a right triangle. And then I have exactly one pair of opposite angles that are congruent. So these angles would be congruent where this angle is not congruent to its opposite angle. So find the indicated values. Let's find the missing angles. So on a kite, we know that one pair of opposite angles are congruent, and it's always going to be the pair that is in between the two non-congruent sides. So 88 is going to be equal to 88 over here. And then a kite is a four-sided figure, and so all of these have to add up to 360. And if you forget that, remember we can do 180 times n minus 2 to get 360. And so to find, we'll call this x, I can do 360 is equal to 88 plus 88 plus 120 plus x. Or you can just subtract them all from 360. And when you do that, you get x is equal to 64 degrees. And then over on number 6, I don't know angle M or angle K. Let's call that X and Y. But we also know they're going to be the same. So I know that X is going to be equal to Y, so let's just call it X and X. And I know they all add up to 360, so just like I did on number 5, I can do 360 is equal to X plus X, or 2X plus 60 plus 50, or 360 is equal to 2x plus 110, which gives me 250 is equal to 2x, or x is equal to 125 degrees. And so that will give me the measure of angle M and K. They are both 125 degrees. Okay, so we'll end with this chart. Just remember, definitions are important. If you know the definitions, then you will likely do well on these problems. If you don't know the definitions, not only on this section, but the sections before, you will probably have trouble setting up equations and solving any problems. And so we have this big picture of quadrilaterals where all of these are four-sided figures, and then we have kites and trapezoids, which are not parallelograms, and then we have all our parallelograms, which includes rectangles, rhombuses, and squares. So make sure that you check your answers on your assignment as you work on it, and if you need to, feel free to rewatch this, work out some examples on your own and pause, and then check your work as you go.